Okay, here we go. We are in week 3. Here's our agenda for the day. We're going to do a quick little warm-up question. We're going to get into some background knowledge. We're going over simple interest and compound interest today. So before we do the assignments for the week, we are going to talk a little bit about those two ideas and what they mean and get into the formulas. Both of these topics have a formula, which means there's an equation with just letters in it, and then you have to plug numbers in for those letters. And then, as always, we will have study hall at the end. And since we are on week 3, I will be going in at the end of class to see what assignments have been turned in and if I need any of you guys to stay so we can get through any assignments and get anything submitted. We will be doing that during study hall. All right, here is our warm-up question. Would you rather get paid or pay more? Let's see. So if you put $1,000 in an account, okay, let's just say you put it in a savings account. You have two options. Option A is earn $50 every year, no matter what. And option B is earn 5% interest, and that interest earns interest too. So every year you earn 5% on whatever's in that account. Which one would you rather do? Do you know what interest means? Maybe, maybe not. Interest is just money that can be added to your account. And the percentage rate tells you a percent of what you are putting in. Okay, we've got a few different answers in the chat. Okay, so option A, every year you're getting $50 no matter what. So if you don't know what 5% even means, if you don't know what interest is, it might just seem like, well, $50 every year sounds great, right? But if you, which we're going to talk about it today, so hopefully by the end of today, you understand it a little bit better. If you understand the difference between simple interest and compound interest, you could make a better decision in this situation. And one day you might have to make that decision. So one day you might be opening up a bank account. Each bank offers a different incentive. And so understanding what those things mean can help you either make more money in the long term or make less money in the long term. This also can apply to credit cards. So if you take out a loan or if you get a credit card, the interest, the interest will be accrued on the amount that you take out or the amount that you have on your card. So these ideas can also play into how much money you might have to pay back later. So the idea comes with savings and also when you take out a loan or a credit card. So we're going to start with simple interest. Simple interest is just like it says, it is very simple. Okay, it is the first option. It's like just getting the same amount every year. So, for example, you earn interest only on the original amount, which means if you put $1,000 in your account, every year you're going to get the same amount no matter how much that account grows. Okay, so it does not change. The interest, the amount of money your account is going to make will not change every year. For example, if you invest $1,000 at 5% simple interest, then that means you're going to earn 5% of $1,000. 5% of 1,000 is $50 per year. So every year, no matter what, you're going to get $50. So that was that option A that we saw on the last slide. So after 5 years, every year you earn $50. So after 5 years, we're going to multiply it by 5. You're going to have earned $250. And then you'll also have that original $1,000 in your account. So 1,000 plus 250 gives you the total amount that would be in there, which is 1,250. Okay, simple interest grows in a straight line, steady but slow. So last week we looked at linear versus exponential. Simple interest is going to be growing on a linear pattern. Okay, so it's growing at a constant rate. The other one, compound interest, is going to be exponential. So see how last week's lesson ties into this one. We have simple interest, which is linear. Compound interest, we'll see in a minute, is exponential. Okay, so simple interest formula. Here is our formula. I is the amount of simple interest you make. So money made. Principal amount is the original amount you put into that account. So in the last example, it would have been that $1,000 that you deposit at the beginning. The rate, R, rate as a decimal. So if it's 5% interest, remember you have to move that decimal over. 5% is equal to 0.05. 25% would be equal to 0.25, or 0.01% would be equal to 0.0001. So remember that decimal moves over 2 times. So if we have 3%, we move the decimal over 2 times over here, and we have to add a 0. So it would be 0.03. Okay, T is the number of time periods. Okay, so if it's 3 years, T would be 3. Sometimes you're going to see like a quarterly payment. That's going to change the number of time periods to however 4 times however many years. And we'll see an example that looks like that today. Okay, so this equation is to find the interest added to the account. So that's going to tell you like that 250 that we looked at before. After 5 years, we earned $250. But the total in the account is going to be found using this formula. So A is the total amount in the account, I is the interest accrued, and P is the principal. Principal, remember, is the original amount that you put in. Okay, so we're going to do a quick example and then we will get into the math-based assignment. So A says calculate simple interest on a loan of 8,580 at 2% per year for 10 years. Round your answer to the nearest cent. Okay, in order to do this, we need that formula. So if I were you, I would take a second, write this formula down on a paper, take a screenshot, do something with it. Make sure you have the title because this one is for simple interest. We're going to get another formula later for compound interest. So our simple interest formula is I equals PRT. So we want to know what is I, because we don't know what that is. We are given that the principal is the original amount. So P equals 8,580. Our rate is 2%, which if I change that to a decimal, it is 0.02. And then our T, our time, it was per year for 10 years. So it's going to be 10. If it was 2 times a year for 10 years, it would be 10 times 2. If it was 4 times a year for 10 years, it would be 10 times 4. Okay? So, but it's only happening 1 time a year, and it's happening for 10 years. So we are going to go ahead and calculate what is I. So we know I is equal to, when you just see these next to each other, these letters next to each other, there's no symbol in between, that means we're multiplying. So we're going to multiply 8,580 times 0.02 times 10. If those dots are confusing you, write the little X's for multiplication. Okay, from here, you can open up a calculator. I don't expect you to do this in your head. Where is my calculator? Let's do this. Oh, it's still not showing up. Okay. There it is. Okay, so we are doing, clear that out, 8,580 times 0.02 times 10. Hit equals. So we get 1716. So I is going to be 1716. That means that after 10 years, we have earned $1,716. We didn't have to do any work. We didn't have to go to a job. All we did was deposit that $8,580 into account. Oh, this is actually a loan. Sorry. This is actually working against you. So if you loaned, so you borrowed $8,580, let's say you bought a car for that amount. Then, after all is said and done, that 10 years goes by, you've made all your payments on that loan. This amount is the extra amount that you're going to pay for that car. So, what is the total value of the loan after 10 years? Well, remember A equals P plus I. So, it's the principal plus that interest. So, A is going to equal our principal amount, which is 8580, plus that 1760 or 1716, sorry. So if we add those together, so we're going to add that to 8580, and we get 10296. So A equals 10,296. So after all is said and done, if we took out a loan for $8,580, in the end, after we pay it back, we're going to have paid actually $10,296. $10,296. Okay? All right. Go ahead and open up MathSpace assignment number 1. We will start that in about a minute. Let me know in the chat when you are ready to go. We are opening up assignment number 3. Okay, let's go ahead and get started. Thanks, Dylan. All right, so if $10,224 of simple interest was earned in 6 years, earned means that's how much somebody made in 6 years. How much interest was earned each year? Okay, well, this one's a little bit simpler. Okay, it's saying in 6 years, we earned a total of $10,224. We want to know how much was earned each year. Well, if it's simple interest, it's going to be the same amount each year. So we're just going to take that 10,224 and we're going to divide it by the number of years, which is 6. Go ahead and plug that into your calculator. Let me know what you get. We had 10,224 divided by 6. Get 1704. So this first one is $1,704. So each year there was $1,704 earned. Now, if we take that amount, if that was earned each year, now we want to know how much was earned each month. Well, how many months are in a year? 12. So we're going to take that amount, 1704, and divide it by the number of months, which is 12. And then let me know what you got in the chat. Thank you, Teresa. Great work. It's going to be 142. So the interest here is 142. So each month, you're making $142. You're not doing anything. So these savings accounts that have good interest rates can really help you guys build long-term wealth. The simple interest rates grow a little bit slower, as you'll see once we get to the compound interest rates, but they do still make you money. So $142 a month, what could you do with $142? That is how much my gym membership is. So could at least pay for your gym membership. I don't know, whatever else you guys are interested in. If you're interested in boxing, I bet it would pay for your boxing membership. Lots of different stuff. Okay, number 2, calculate the simple interest earned on an investment of $5,650 at a 2.1% interest per quarter. Okay, per quarter means that it's happening 4 times a year. 4 times, which means we're going to have to multiply that by the 7. So when we write down our letters and what they equal to, we will take that into consideration. This is asking for the simple interest, so we don't know what that is. That's what we're going to find. We need to know what P is. P is the principal amount, so the main amount put in the account. In this case, it's $56.50. Our rate is 2.1%. As a decimal, it's 0.021. And then our T, it's 7 years, but it's 4 times a year. So that means we're going to take that 7 and multiply by 4. So we get 28. And now we just plug everything into our formula that we have right up here. So we have I equals P is 5650 times 0.021 times 28. Go ahead and plug that into your calculator and let me know what you get in the chat. I'm getting a number that's in the 3000s range. I got I equals and I lost it. 3,322.2, which means it's 20 cents. So $3,322.20. So that would be your answer here. Okay, moving on, we're looking at compound interest. Okay, this is the next type of interest we are looking at. In this case, money is going to grow a little bit faster. So remember I said that with simple interest, it was linear, so it was growing at a constant rate. With compound growth, it is exponential. So it's going to start out slow and then it's going to shoot up really fast at some point. So what is compound interest? You earn interest on the original amount and past interest. So your money starts to grow on itself. So what that means is if you invest $1,000 at 5% compound interest, the first year you're going to make $50. The first year you make $50, which is the same as the simple interest. But the next year you're going to take 5% of this new number. Okay, so 5% of that number. And 5% would be 0.05 times 1050. That next year, let's see what we're making. We're making 52.50. So we're making a little bit more. So each year, the amount that you make is going to increase. Okay? So your interest keeps getting bigger. After 5 years, your total amount is going to be much higher than that 1250 that we were going to have with the simple interest. So compound interest grows on an exponential curve, slow at first, then faster. So again, it's going to go like this, and then it's going to, oops, that shouldn't have done that. It's going to slow and then first, and then fast. Okay. All right, so here is your formula for compound interest. Again, if you want to screenshot this little box here so that you have it, or write it down, but make sure you have the word compound interest so that you know this is the formula for compound interest, not simple interest. Okay, A is the final amount of money. So this is the total amount in the account or the total amount on the loan after however many years. Okay, so now we're not just calculating the interest earned, we're calculating the total amount. Principal, again, is the initial amount of money invested. R is the interest rate per year expressed as a decimal, and T is number of years. And remember, number of times per year is going to matter. So we'll have to keep in mind if we see that it's compounded monthly or compounded quarterly, that's going to change things a little bit. And I'll help you with that. Okay, so here's our example. It says Sean's investment of $7,000 earns an interest rate of 6% per year. Compounded annually. Compounded annually means every year. So once a year, so we don't have to do anything with that. And the time is 4 years. So we have our P. That doesn't look very good. Here's our P. Here's our R, but remember we want to turn it to a decimal, so it's 0.06. And then here is my T. And we want to know what is the future value of the investment. So we want to know what's A. So formula was A equals P times 1 plus R to the power of T. So we're working with exponents again. We did practice with these last week. So if you didn't see or didn't come to class last week, I would go back, watch the video. It is posted on the agenda. Okay, so our P was 7,000. So we're going to have A equals 7,000 times 1 plus our rate as a decimal, which was 0.06, all to the power of T, which in this case is 4. Now, there's some of this that I can do in my head. Like I can add these together in my head, right? 1 plus 0.06 is just 1.06 to the power of T. Oops, that should be a 4. To the power of 4. And then we still have that 7,000 being multiplied. So now in my calculator, I always do this part first, and then I multiply by 7,000 at the end. So let me show you. Um, if you go 1.06, and if you hit this button that has x to the power of y, this one here, x to the power of y, and then you put your exponent in, which in this case ours was 4, it should put a little exponent up in the corner. And then I'm going to go equals, and then after I do that, I will multiply by 7,000. So you get 8,837.338. 8,837.338. I think that's what we had. Let me double check. 8,837.338. Yes. Okay. So I wrote down three numbers after the decimal because I want to be able to round. So remember, when you're looking at money, you only want to go to the hundreds place, right? Because you want it to look like cents. So looking here, I have a 3. The number next to it is bigger than 5. So that means I'm going to round up. So A equals 8,837.34. Okay. Go ahead and open up math-based assignment number 4, and we will get started. I know this looks like it has a lot of parts, and it does, but it's not as bad as it looks, I promise. Let me know in the chat when you guys are ready to go. Otherwise, we'll start in about a minute. We are starting at 1:30. We will start the math-based assignment. Okay, we'll go ahead and get started. Hopefully, you guys are ready to go. All right. Thank you, Dylan. $9,000 is invested at 2% per year, compounded annually. Okay, so we've got this number here is going to be our P. This number here is our rate. If we express it as a decimal, it's 0.02. Compounded annually means it's one time, so we don't have to do anything with the time. Okay, the table below tracks the growth of the principal over 3 years. So 1A says what value should go in cell A? So we want to know at the end, so we start with $9,000. We want to know what's the interest earned in 1 year. So we're going to take our formula, which I have it up here, and we're going to plug in everything we know. Oh, well, actually, to keep it simple, all we need to really do is figure out what's 2% of that 9,000. So 9,000 times 0.02, and that will tell us how much interest was earned in 1 year. 9,000 times 0.02. It's $180. So value in cell A should be 180. Okay, what should go in cell B? So now we're looking at this one here, and we want to know the value at the end of the time period. So if we earned $180 and we already had 9,000 in there, it's going to be 9,000 plus 180, which is 9,180. So this one should be $9,180. So in here we have 9,180. Okay, 1C says what value should go in cell C? So now we're looking here. Well, at the beginning of the period, it's going to be whatever we left off with in the last period. So it's going to be the same as what's in cell B. So this one should be also 9,180. Okay. What value should go in cell D? So now we're looking here. So we know if we started with 9,180 and now we've got this 9,363 and we want to know how much interest was earned. We started with this. Now we started with this one. Now we have this one. What's the difference between the two? We just have to do 9,363.660 minus 9,180. Go ahead and plug that into your calculator, see what you get. I got 183.6. Since we're talking money, we need that 60 at the end. So the answer here is 1,000. Sorry, not 1,000. 183.60. So that's what's going to go here. 183.60. Okay, and lastly, what value should go in cell E? So now we're looking at this one here. Well, we started with 9,363.60. Now we have 9,550.87. So again, we're just finding the difference. So 9,550.87 minus 9,363.60. Go ahead and put that in your calculator and see what you get. It's good for you guys to test your own calculator work to make sure you know how to use your calculator correctly so that I can answer any questions you have. Okay, and I'm getting 187.27. So 187.27 should go here. Okay, and then 1F says, what is the total interest earned over the 3 years? Well, it's all of those added together. So 180 plus 183.60 plus 187.27. So add those all together and see what you get. I love seeing you guys drop those answers in the chat. So if you do have it, go ahead and drop it in there. I have got 550.87. Good. So this should be 550.87. Okay. This is actually math-based assignment number 2. I forgot to change that number there. Okay, so this is a good little tip to have. Notice we are compounding quarterly. Why is that not writing? Compounding quarterly, which means it's going to change the formula a little bit. So I'm going to help you with that. We're going to get through it, but it is going to change it a tiny bit. Just be aware. All right, so a $6,490 investment earns interest at 4.6% per year, compounded quarterly over 4 years. Use the compound interest formula to calculate the value of this investment to the nearest cent. Okay, so we know A is what we're looking for. P is the principal interest, so the number that we originally invested, which in this case is 6,490. R is the next thing we need. In this case, R is 4.6. So when we convert that to a decimal, it is 0.046. And then T is the time. T is going to be 4 years times it's compounded quarterly, so we have to multiply that by 4. Okay, so that's going to give us 16. And then we also have to, when we do the formula, we have to divide the rate by R because that's the annually rate. So we have to divide that by 4 to find the quarterly rate. So if we divide 0.046 by 4, we're going to get 0.0115. So now we can plug everything into our formula. We have A equals our P, which is 6,490 times 1 plus that rate, which in this case is 0.0115 to the power of 16. Now this part I'm going to do in my head again, just like I did last time. We get 1.0115 to the power of 16. And I'm going to copy the rest down. Okay, so now this is the part where I put it in my calculator. Again, I'm going to show you guys how to do this. So we had 1.0115. Make sure that was the right number. Yeah. To the power of, so remember, use this button here. To the power of 16 equals, and then we're going to multiply by that principal amount, which was 6,490, and we get 7792.896. And remember, I write down 3 numbers after the decimal point because I know I'm going to have to round. So looking at this, I've got a 9. Look at the number next to it. It's a 6, so that means I'm going to have to round up. But I can't change 9 to a 10, so I have to look at this whole number. I've got 89, so I'm going to round 89 up to 90. So we have 7792.90. So 7792.90. Okay, we are going to have study hall time now. I'm just looking here. Let me just check the grades and I will I'm going to send you guys a personal message letting you know whether or not you are able to go or if I need you to stay and work on an assignment or two with me. Okay. 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 If I gave you an assignment that is like one of the math-based assignments, I'm going to post a link in the chat and I'm going to show you what the link is. And then, but I also want you to have access to it. So here is the link. And even if you don't have an assignment that you need to do, you might want to open up this link just so you can follow along. Let me, I'm going to replace the current share. Okay, I'm going to show you guys this. This is a document that I am creating as the weeks go by, and it just has the slide decks on it. But the good thing about it is that it has the math-based assignments completed. So if you look at it, and there's tabs over here that'll tell you where to go. So last week we did assignments 1 and 2. So if you go to week 2, and look at the agenda, you'll see, oh, this one's going to have assignment 1 and assignment 2 completed. So if you scroll through, it'll show you how to do the work, but then it'll also give you the math-based assignments. So you can open up task 2. Oh, these are kind of out of order. I need to fix this. Where's task 1, number 1? I found a mistake here, I think. Let me see. We need task 1, number 1. Anyways, this has the tasks on it. Task 2, number 1, task 2, number 2, task 2, number 3, and number 4. Okay. And then if you go to week 3, this one has the slides from this week. I posted these yesterday after I taught. So next week, you'll see week 4, and it'll have the slides for number 4. It goes through all the examples, all of the problems, and the math-based assignments. So you should be able to access this stuff even if you happen to miss class 1 week. Now, let me see if I can. I'm going to stop sharing. Okay, I'm going to put on some music for us to work to. If you have any questions, please let me know in the chat. Otherwise, you should be working on whatever assignment I gave you in the chat.